one point, we solve. Well, we use the equation or the Pythagorean theorem, x squared plus y squared equals to 1.
This we don't call Pythagorean theorem. This is a presentation for unit circle.
Unit circles. Okay.
Right.
So yeah, use the equation x squared plus y squared.
Right. X squared plus y squared equals 1. That means the point x comma y is on the unit circle.
Yeah.
Okay.
So that you plug the variables with the x and y's. So for example, you do -5/13. You put that for x. You square it, you get 25/169, and for y you get 12/13 squared. You get 144/169, and you add across 25/144. You get the same number as the denominator. That's where we get our 1 point right there.
Right. But it's better to say, right. So we have a common denominator 169 for those two fractions. Now we can add 25 with 144, and we get 169. And 169 divided by itself, that equals to 1.
Yep.
So what's your conclusion?
So when you end up with when you have two similar numbers, you have to make sure that it equals to at least 1 point, because otherwise it's not on the unit circle.
So what's your conclusion? So the question is this point on the unit circle? What's your answer?
Yes, so it is, because we have two similar numbers that equal to just 1 point, and it does appear on the unit circle.
No, Samia, let's try to see this. So this one is on the unit circle because it satisfies the equation here. When we add x squared plus y squared, we do get 1.
Yes.
So right, it satisfies this equation. The x, y value satisfy this equation. That's why. So this equation is equation for the circle. Okay. All right. Good, Samir. Thank you.
You're welcome.
Anybody has any question? Okay, good. So let's see. Jeremy. And Juliana.
Okay. Am I presenter?
Yeah, please.
Am I presenter?
Oh, have I? Yeah, I made your presentation ready.
Okay. Do you see it?
Yeah.
Are you able to see?
Yes.
Okay. So is that okay?
I'm sorry. I think your voice is on and off.
I would like to present 38C. Is that okay?
Yeah. Actually, you know what? Do A,
Okay.
B, C, D, because you have all the answers here. It's good review for last class.
Okay.
Thank you.
Okay. So yeah, it's I found it like simple. Like I did my best. For A,
What's
I
this
had
question?
put T equals to 11.
Remind us what's the question. What do we have to do?
Okay. Here you go. 30. Question 15. I'm gonna get to it. Is it okay if I have a minute to find the question?
Okay. I think if I don't remember wrong, we have to find the reference angle, right? The reference number.
Yeah, something like
Yeah.
That was the question.
Right, that was the question. So we have to find the reference number because the angle can go infinitely big, but we're working with a unit circle.
Yes.
Working with a unit circle. So we want the number strictly in between of 0 to pi. And then we can look at the triangle. Yes. So we can look at the triangle, right triangles. Then the angle is limited with from 0 up to pi over 2. So we want to find a reference angle of the angle in a triangle. But these triangles could be in the first quadrant, second quadrant, third quadrant, fourth quadrant. So we need to figure out, where is the angle lay. So we draw the angle first. Then we draw the triangle. Then we find the reference angle. Okay, go ahead. Let's see 8.
Yeah. So 38, I found myself getting pi over 5 because I saw.
If we draw this
If
angle,
I'm not mistaken.
no, it's okay. If we draw this angle, 11 pi over 5, which quadrant it falls? Which quadrant is this angle? Positive angle, we draw, what do you call it? Counterclockwise, right?
Counterclockwise, right? So it's.
Right, counterclockwise.
So I'll be like in.
Yeah, then which angle? So which quadrant this angle ends?
So is it like the fourth?
A fourth? If in the first quadrant, that means this angle is less than 2 pi.
Yeah.
Is it 11 pi over 5 less than 2 pi or bigger than 2 pi?
Is that bigger?
It's a bigger, right? Because think about it, 11 pi over 5 can be split into 10 pi over 5 plus 1 pi over 5.
Right.
Now what's 10 pi over 5?
10 pi over 5? That's
right.
like 2, right?
That's 2 pi, right? Right, 2 pi make one circle. So 2 pi make one circle. So let me write in the chat. So 11 pi, so 11, I'm only going to write the numbers. 11 pi over 5 equals 10 pi, 10 over 5 pi plus pi over 5. That's what you have. And we can ignore the 2 pi. So 10 over 5 pi is just like you said, it's 2 pi. 2 pi plus pi over 5. And 2 pi, the 2 pi just made one circle. Made one circle, we can ignore it. The coterminal will be same as pi over 5.
Okay.
So that's why your answer is pi. That's why you figure out, you said, okay, 11 pi over 5, I can write as 10 pi over 5 plus 1 over 5 pi. Then 2 pi I can ignore. I get a pi over 5. Or maybe you can think like what you wrote. You wrote here is 11 pi over 5 minus 2 pi.
Yes.
Like 2 pi and 0 is the same. 2 pi, 4 pi, 6 pi is the same as 0. Is at 0 angle. So that's why you have pi over 5. Okay, good. All right. Let's try B.
B, I kind of guessed. I wasn't sure about that one.
Okay, that's a negative 9 pi over 7, right?
Yes.
So negative angle we measure clockwise. So we would go down from that positive side of x-axis.
Right.
Right. So can you try to figure out which quadrant this angle ends?
For minus 9 pi.
Minus 9 over 7 pi.
So if it's like clockwise, would that be somewhere like on the right?
So which quadrant? We have 4 quadrants, right? First quadrant, second quadrant, third quadrant, and fourth quadrant.
So wouldn't that be like in fourth or something?
Well, you know what? Let me try to so let me try to write those. So the first one is 11 pi over 5. Second one is negative 9 pi over 7. C equals 6. Okay, let's not talk about. Oh, we can talk about the number. 6 and D is negative 7, right?
Yeah.
Okay, I'm gonna go to the whiteboard. So I hope the rest of you, if you know it, you can join us. Let me draw here. So the first one is let's try, so everybody can understand this. Over 5 pi. So we can split this into 10 over 5 pi plus 1 over 5 pi. Hope everyone is okay with this. But this we just covered the last class. You don't see anything yet? Or maybe I need to do this. You see it now? 11 over 5 pi equals to 11. Oh, okay. So I have to press the enter key. So let me draw the picture. Let's see how do we figure out. How can we figure out the angle? Okay, so it's 11 over 5 pi, right? Let's mark our numbers. So this is a 0 angle, the positive side of x-axis. This is positive side of y-axis. This is a pi over 2, right? So 90 degrees. Oops. Let's make sure we understand this. So how do we measure angles? We measure angles this way, right? From this positive side of x-axis up to here, that's pi over 2, right? That's 90 degrees. If we keep going, a straight line is a pi. Pi or 180 degrees. Or if we keep going, we add another 90, right? We have 190, 290, 390. So this is 3 pi over 2. If we keep going, so we have 490 degrees, right? That's 360 or 2 pi. That's why in here we say, okay, this is here is a 2 pi, 0, 2 pi, 4 pi, 6 pi, so on and so forth. All the even pi's. All the even pi's, the angle ends up at 0. Does this make sense? If anybody has any question, let me know. So now let's draw. So we have this landmarks, right? We have 0, 2 pi, 4 pi, 6 pi, positive side of x-axis. And the positive side of y-axis is pi over 2 plus 2 pi plus 4 pi, so on and so forth, plus all n pi's. And the negative side of x-axis is a pi degree. So going from here, walking straight line is 100 degrees or pi. This could be pi, 3 pi, all the odd pi's, 5 pi, so on and so forth. All the odd pi's in here, and at this. Because we're measuring angle this way, right? Then down here, that's 3 pi over 2 plus 2 pi plus 4 pi, so on and so forth. Okay, make sure we remember those 4 landmarks. So 0, pi over 2, pi, and 3 pi over 2. Okay, now let's figure out 11 pi over 5. So what is the number 11 over 5? 11 over 5, oops, equals to 10 over 5 plus 1 over 5. Right? So only look at the numbers. We can carry pi with us later. So 11 over 5, that's 10 over 5 plus 1 over 5. And what is that? 10 over 5 is 2, right? So that's 2 pi plus 1 over 5 pi. So the angle is like this, 11. So 11 over 5 pi, 11 over 5 pi. Okay, it's positive. We start from positive side of x-axis, right? Going counterclockwise. 2 pi, come back to 0, right? That's 2 pi. Then we keep going. We need to add 1 over 5 pi. So the angle is somewhere here. So what is the angle? The angle starting from positive side of our x-axis, run around, run 2 pi, then run another 1 over 5 pi. So what is the reference angle? Well, let's drop. So this is the point we end up with. We connect with the origin. We have this called co-terminal line. So this is called a co-terminal line. Why is it called a co-terminal? Because this is the pi. So this line is for 1 over 5 pi, 11 over 5 pi, so on 13 over 5 pi, so on and so forth. So many angles end up at this line. That's why it's called a co-terminal line. You see 1 over 5 pi ends at this line, and the 11 pi over 5 also ends at this line. So this ends in the first quadrant, right? Jeremy, make sense?
Yes.
You see the angle in the first quadrant. So in the first quadrant, we drop a straight line to the x-axis.
Okay.
Now we work with this triangle. So now can you tell me the reference angle from this picture? That's just this one, right?
Is it from like this triangle?
That's this triangle I just marked. Because we're
So is
looking
that,
at
so that I see like the negatives are here.
what do you mean negative?
Is it like is this negative 3 pi?
Oh no, that's not negative 3 pi. This is supposed to be comma.
Okay.
That's 3 pi, 5 pi, 7 pi. All the other pi ends here. All the other pi. You think, let's see. We're running around as 2 pi, right?
Yeah.
We run here, 3 pi. We keep running 5 pi. We keep running 7 pi. We keep running 9 pi. All the other pi's enter at this line.
Well,
All the even pi's enter here, right? So 0. That's why if it's 2 pi, 4 pi, we can ignore. If even pi's, we can ignore. Because 0 is here, we run one circle, that's 2 pi, same point. We run another circle, 4 pi, same point. We keep running all the even pi's ends here. Okay, so 11 over 5 pi, the reference angle is 1 over 5 pi, right? Because we can ignore the 2, ignore 2 pi. The 2 pi come back to 0. So this angle, 11 over 5 pi,
so it's like, so is it like it goes to the other side?
it doesn't go to the other side, right? Right here, right? You see this angle? Let me use a blue, green color. You see this angle right here? You see the triangle I made?
Yeah, I saw it. I see it.
Yeah. So the triangle. What's the reference angle? Reference angle is here.
Okay.
This is the reference angle. If we talk about it on the unit, oh, actually, my triangle is made too big. If we're talking about, because I'm using this circle, so let's say this is our unit circle, because we're talking about unit circle. So let's say this blue circle, no, green circle is a unit circle. Unit circle means this radius is 1. The radius is 1. So this point is on the unit circle. And then we drop a line to make a triangle. And then what is the angle of here? That's pi over 5. All right, let's see the second one. Second one is negative 9 pi over 7. It's negative. It's measured negatively. So negative 9. So let me change it to my color. Negative 9 over 7 pi. Okay, how do we measure negative number? Measure negative angle. We measure counterclockwise. We start from the same. Let's do on the unit circle, all right?
Okay.
We start at 0. But since it's negative, we go clockwise. We go clockwise. A negative 9 over 7 pi can be thought as negative 7 over 7 pi minus 2 over 7 pi. Let's see, make sure this makes sense. Because we need to figure out which quadrant this angle ends. Because the denominator is 7, right? A 9 has 1 7 in it. 9 can be thought as 7 plus 2. So that's why I break a negative 9 over 7 as negative 7 over 7, negative 2 over 7. Does this make sense?
Yes.
Okay. So now negative 7 over 7 is just negative pi, right?
Yeah.
So let's do that. So now let's draw our angle. So we start with on the unit circle, we start at 0. Oops. We start at this 0. So we run negative pi. This will be negative pi, right? So this is clockwise, negative pi. Then we need to measure another negative 2 over 7 pi. Negative 2 over 7, yeah, somewhere here. So let's keep going. Maybe somewhere here. So approximately, right? So the point ends here. Now let's draw the triangle. So we connect the point with the origin. Then we drop a line, a perpendicular line to the x-axis from the point. So we see this right triangle. Now, where is the reference angle? Reference angle is this angle. We always talk about the angle around this origin. This angle in the triangle.
Okay.
Okay, so can you tell me what's the reference angle?
For negative 2 over 7?
It's not. It's no more negative anymore, right? Because this angle inside the triangle cannot be negative anymore. Just 2 over 7 pi, right?
Yeah.
Yeah. So the reference angle for negative 9 over 7 pi is just the angle inside this triangle. So we need to draw a picture. So we need to draw a picture. We need to figure out the angle, which quadrant that angle in. So this is right. So here, so reference angle for negative 9 over 7 pi is 2 over 7 pi. Okay, anybody has any questions? All right, so for C is 6. Jeremy, you want to try C?
No, I'm sorry. I'm not comfortable.
No, right? Okay, let's do C altogether.
Yeah.
For C, the angle equals to 6. Let me use a black color. Oops, already wrote. So what about 6? So 6 is in radian form. That means 6 radian. So pi equals to 3.1415, you know, so on and so forth, right? So pi is radian. So 6 is a little bit less than 2 pi, right? So 6 is less than 2 pi. So very close to it. Very close to it. So we know that ends in the 4th quadrant. So let me change the color. So I start from the 0 point. I start at a 0. Because the 6 is positive, I go counterclockwise along this unit circle. It's almost 2 pi, but a little bit less than 2 pi. So end somewhere here. So that's the point. So I need to draw the triangle. So I'm connecting this point with my origin. Then I drop a straight line, perpendicular line to the x-axis. So I see this triangle. I work with this triangle. So where is my reference angle? That's this angle. This is my reference angle. So how do we write this? So the reference angle is, we say it's 2 pi minus 6, right? The reference angle is 2 pi for 6 is 2 pi minus 6. And last one, t, -7. So t equals to -7. -7 is a little bit bigger than 2 pi, right? A little bit bigger than -2 pi. Because 7 is bigger than 2 pi. So we think -7 is a bigger, but it's bigger than -2 pi because it's a negative. Oh, hold on, it's smaller. It's smaller than -2 pi, right? But 7 is bigger than 2 pi. 7 is bigger than 2 pi. And 7 is bigger than 2 pi. Now let's measure. Let's use this color. Because the negative, now we go clockwise. We go clockwise. So 7 is bigger than 2 pi. So we go one round, right? That's 2 pi, -2 pi. Then we have to go a little more. We have to go a little more. Well, let's pretend we end up somewhere here. So we see a triangle. We see this triangle. And then what's the reference angle? The reference angle is just this one, the 7 minus 2 pi. So the reference angle is 7 minus 2 pi. So the key is we have to draw this picture to figure out reference angle. We have to draw the 4 quadrants, right? To label the angle. First, we need to label the angle. Once we have the angle, right? We could end up at the first quadrant. Then we work with this triangle. What's the reference angle? The reference angle is this one. If it ends at the second quadrant, we work with this triangle. And the angle will be this angle. Or the point could be on the third quadrant. Then we work with this triangle. The reference angle would be this one. Fourth quadrant similarly would be this one. The reference angle will be this one. Okay, anybody has any questions? All right. Okay, thank you, Jeremy.
Yeah, thank you. No problem.
Okay, does this make sense? It's a lot.
Yep. Yeah, it is.
A lot. Yeah, that's why trigonometry is very difficult at the beginning. Yeah. But we'll spend time on this.
All right. I just got to keep trying, you know?
Yeah.
But, yeah, no problem.
We'll spend more time on this.
Yeah, no problem.
Okay, thank you. Thank you. Let's see. Juliana, you want to show 5?
Yes, I'm going to share my screen now.
Okay.
It's not showing. Hold on. I don't know why it's not showing up.
Yeah, sometimes it's tricky. Or maybe you can explain. So it's a homework 14.5. Maybe you can just talk about it.
I'm sorry, I don't know why it's not working.
Do you like to use the, what do you call it? The whiteboard?
Can I?
Yeah, you could choose the whiteboard. You could just like what I did, write on it. Write on the whiteboard. Or maybe you could just talk about it. Talk about what was the question, you know, how did you give the answers?
Okay, so for question 5, it was basically to show if the point was on the unit circle. So what I did was I basically plugged in 7/25 and 24/25 into the equation. So I squared that, added them together, and equaled it to 1. And then I solved it to see if the equation was true. So I squared 7/25, and then I squared 24/25 using the product property.
What do you mean product? Okay.
Product rule, I think it's called. And then that gave me 49/625 plus 576/625, which then I basically just, since the denominators were the same, I just added 49 and 576, and that gave me 625/625, which equals 1. So that proves that the point is on the unit circle.
Great. That's it. Great. Okay, good job,
I'm
Julian.
sorry I couldn't show it.
It's okay. That's okay. You explained it very clearly.
Okay, thank you.
Anybody has any questions? All right, let's go next one. Tijeta, right? Tijeta, you want to show 14.1?
Yeah, yes.
Okay.
Okay, so I'll be presenting number 1. So it says the unit circle is the circle centered at the origin in the x and y plane with a radius of 1. And B, the equation of the unit circle is x squared plus y squared equals 1. And C, suppose the point P xy is on the unit circle. Find the missing coordinate. So number 1, they give us P and they give us the x coordinate, the x. Now we need to find the y, so I put y over there. And then when you have a P and E, sorry. So for the second one, number 2, it's a blank comma 1. So it's x comma 1. So number 3 is P. When P is -1, that's comma y. And number 4, last one, P is x comma -1. Is that right, Professor?
What do you mean? You haven't finished yet, right? You need to tell what's y, what's x, right? You have 1, 2, 3, 4. If you know x value, right, you should know y value, right? So you need to solve for, you need to find out y, find out x, right?
Yeah. So when P is 1, that means Y is
No, not P is 1. P means a point. A point has
sorry.
right. So the first one gives you x value. If x is 1, what's a y value?
0.
0, right? Y is 0. Can you prove it?
If I look at the unit circle,
Good job, right?
yeah.
What the unit circle gives you?
Okay, let me look at it.
It's right here. You have your unit circle on B. You know, you have x squared plus y squared is 1. Now you're
Yes.
given this point, x value is 1. If x is 1,
So I just plug in.
right?
Yeah.
You plug in, right? Then what?
So since Y is 1, so that will be 1 square. 0 squared is 0, and it is equal to 1, and then I solve it.
No, you don't know it's 0 yet, right? You know this y,
Okay.
right? You know y. So you have 1 squared plus y squared equals 1. Then can you go from there to solve for y?
Can you repeat that please again?
Okay, you see the first point, you see all those 4 points, right? Gives you either
Yeah.
x or y value.
Mm-hmm.
And then you said that you're going to use the unit circle equation to solve for the other variable. So let's see the first one. The first one, you know x equals 1.
Yes.
So how do you use the equation to solve for y? Because y is unknown here, but you need to put a value for y.
Okay, so what I will do is, since x is 1, 1 square is 1, so I will move 1 to the right side, and then I have y squared is equal to 2, and I will use a square root to eliminate the square, and I will have y is equal to like 1 point something, because square root of 2 is
No. Okay, when you square 1, that's 1, right? 1 on the left-hand side.
yeah.
So you have 1 plus y squared equals to 1. You need to subtract 1 instead of adding 1 to both sides, right?
I mean subtract because it's addition already. Yes, you're right.
Right, then how do you change your answer?
It will be 0.
That's right, you have y squared equals 0.
Yeah.
Then that means your y has to be 0, right? Okay,
Yes.
so can you also try to do 2? Find the
Okay,
x?
so all right, so 2, basically I'll do the same thing. Since I know the y over here, the x is unknown, y is is 1, so it will be 1 square, which is 1, so I will do -1 on both sides, and I have x squared is equal to 0.
Right, if
And
x
then
squared is 0, then x is, if x squared is 0, x is 0, right?
Yeah.
Right. So now you have your first one, the y is 0. The second one, the x is 0.
X is 0. Yeah.
Right. Now can you do 3 and 4? You need to
Number
solve for
3. Okay. So number 3 will be since I have the x, I will plug in. So -1 squared plus y squared is equal to 1. So -1 squared let's see. -1 squared is 1. So I will move one to the right side, and I will be left with y squared is equal to 2. Am I right?
You're wrong.
Okay, let me start over.
Can
Can I start over?
Sure.
Okay, thank you. Okay. Okay, so for number 3, they give me the x value, -1. So to plug in into the equation will be -1 squared plus y squared is equal to 1. So -1 squared, it's is that 0?
-1 squared equals to 0?
I'm not sure. -1 squared is equal to -1.
Well, let's do -1 squared in the chat. Okay, can you read in the chat?
-1 squared is equal to 1, isn't it? Let me see.
Right, -1 squared equals to -1 times -1. Negative times negative number.
Which is 1.
Which is 1, right?
Yeah.
-1 squared equals to 1. Okay, good.
Yeah. So I have, and then I have 1 plus y squared is equal to 1. So I'll remove the 1 by doing -1 on both sides. So I will have y squared is equal to 0.
If y squared equals 0, what's y?
Y is 0.
Y is 0, right? Because
Yeah.
only 0 times 0 is 0. Only,
Yeah.
0 times 0 squared.
Yeah.
Okay, now can you try 4?
Yeah, of course. All right. So number 4, they're giving me the y value, -1. So it will be x squared plus -1 squared is equal to 1. So -1 squared is 1. So I will do negative on both sides to remove the negative, to remove the 1. So it will be x squared is equal to 0. So x is equal to 0.
Okay, so now you're sure about the answer, right? Now you can change your spots. It's not y. The first one should be 0.
0,
The second one is 0. All those x, y should be 0.
Yeah.
Those 4 are special points on the unit circle.
Okay.
Let's draw a unit circle.
You said to draw a unit circle?
No, I'm drawing. Can you see my?
Yeah.
Right. So just pretend that this is a perfect unit circle. There are 4 special points. This point, let me use a different color. This point, this point, this point, this point. All the x, y's have a, for all x, oops, let me use this color. For all x, y, if it's a unit circle, that means x squared plus y squared equals to 1.
Equals to 1, yeah.
Right. But those 4 are special points. Can you give the name of those special points? Let's see this one, the first one here. Give x value, y value.
For the first one?
Yeah, for this one.
X,
can you see the pointer?
I see the green points, but I don't know which one. The one in first quadrant?
The one in the first quadrant, right. On positive side of x-axis.
It will be 1, 0.
1, 0. Great.
Yeah.
So this is one of the points you just solved. They give you x value 1, you just solve the y to be 0.
The y.
Okay, we
Yes.
go on the y-axis, the positive side of y-axis. What's this point?
It will be 0, 1.
Good job. And then on the left side of x-axis.
Since we are already on the negative side, so it will be -1, 0.
Good. And the down on the y-axis.
The y-axis for the fourth quadrant is negative, so it will be 0, -1.
That's it. That's the 4 points you just gave. You see that?
Yeah.
You're given the 1 value, but the rest of it has to be 0. Okay. All right. So those are 4 special points on the unit circle.
Okay.
All right. Good. Thank you.
Thank you, Professor.
Thank you. All right. Let's see next one. Anna wants to show homework 1345.
Yes.
It'll be good review. Okay.
Here. Okay. Can you see?
It's coming up. Yes.
Okay. So here we ask to solve the logarithm equation for x. So here to solve this one, I use the product rule. So it's log a times b times c.
Anna, let's read log base a of
Yeah.
times c.
Yeah, log base a b times c.
Good.
So here I place log 2, 3 log base to 3x equal log 2, and then here I distribute the 5 x
No, how did
minus
you get
2
Anna, let me ask you a question. How did you get 3x?
from here.
Good job. Right.
Yes.
Okay.
So and this one, the distribution I got it from here. 5x minus 2. So then I got 5x minus 10. So and here I have to, this is the first step, but then I have to place the number with the same variables together. So
Okay, before that, Anna, how did you get it from step, let me see, 1 to, from the second step to the third one?
From here
log
to here?
2 of 3x, right.
So here, these one are the same. So it's going to cancel.
Okay, good job. Because
I did that.
log,
Yeah.
right, we have log base 2 on one side, we have log base 2 on another side of something, then of something have to equal to each other. Good. Keep going.
So then here I place it same variables together, and here to get this number, this here, I subtract 3 minus 5x. So then give me positive 2x equals 10. And then here I have to divide. So 2 divided by 10 equal, then I got my x equal 5.
2 divided by 10?
I mean 10 divided by 2. Sorry.
10 divided by 2, right. Okay. All right, good job, Anna.
Okay, thank you.
You're welcome. All right, good. Trigonometry is difficult. Let's talk about trigonometry. Okay, Sarah, we have Sarah, right? Sarah, do you like to show something? Hello, Sarah, are you there? All right. Okay, anybody has any questions? Sarah, can you hear me? Sarah, can you choose one from your homework to show it? I'll help you. Okay, Lisbeth, do you like to show anything? Do you like to earn presentation credit?
Yes, let me just take a look to the homeworks I sent.
Okay. All right, Sarah, can you hear me, Sarah? Oh, okay, you did? Okay, let's see. Sarah, but I can hear you. I can hear your voice. I see, I see. You don't have a video. It's not a video, right? It's just a recording. I got you. Okay, Sarah, somehow, so you only recorded, right? Remember the presentation, right? Okay, anyway. It's better to present in the class, all right, to get full credit. But sometimes I ask you questions. Okay, anyway. So waiting for Elizabeth. Elizabeth, anybody has any question?
I'm preparing myself. I'm almost done.
Yeah. So only Jeremy tried to show homework 15, which is regarding trigonometry, the second part of trigonometry. So about the trig functions, sine, cosine, right? Sine, cosine is defined on a right triangle. And also we have, put a right triangle on 4 quadrants. On 4 quadrants. So we said, all students take a calculus to help us to remember the positive, negative values of those trig functions. So we're gonna go over that since not many of you showed the work. You know, it's kind of difficult. But I'm gonna go over that again after this present. All right. Hopefully you ask me questions. You know, whenever I don't make sense, you have questions, you know, ask, please. All right. Because really, if you want to take a calculus class, you don't have this background, it'll be very difficult to understand calculus ideas. Usually people fail. I teach 2 classes in Hunter College. Both classes are calculus class. Students not fail on the concept of calculus. The concept of calculus is not difficult to understand. But students fail on this, you know, understanding those functions. So this class is, you know, is all about to help you to build up this knowledge of functions. All right, Liz, I see your screen. So which one you want to present?
I'm going to be working on 36.
Okay. Oh, okay, great.
So we are so basically supposed to find the reference number of the value t. So we have t equals 5 pi over 6. The first thing is to subtract pi from 5 pi over 6. This is because like okay, I'm sorry. The angle is like on the second quadrant. So we subtract pi from this the 5 pi divided by 6. If it was like on the on like the fourth quadrant, we would subtract this from the pi. Then we write pi as like a fraction with the common denominator. So our denominator number here is 6. So we put pi multiply over 6 minus this, which is 5 pi over 6. Then we just basically like combine it, and for like a pi multiply like 6, and it would just basically become this, and then over 6 minus 5 pi divided by 6. After that, we combine. You have any questions?
Yeah, go ahead. I thought you finished.
Oh no, not yet. After that, we just basically combined the denominators, and it becomes like pi multiply 6 minus 5 pi, and then this just becomes like 6 because these are the same. So then it would be okay. I would just basically move like the 6 to the front, so it could be like 6 multiply pi minus 5 pi. And then I just basically subtract pi from 6 pi, because if we multiply this together, it just becomes 6 pi. And then this is 5 pi. So we just subtract it. And we know that we don't have to basically put the 1. So we just put it as a pi. And the denominator stays the same always. It doesn't change at all. And so it becomes pi over 6.
Okay, 1 pi minus 5, that's 1. 1 pi over 6. Usually we don't write a 1, so 1 times pi is just pi. Okay, I have a question. So how do you know 5 pi over 6 ends up at the second quadrant?
Well, I actually found that on the unit circle.
Yeah, good. Can you try to draw the unit circle? Go to the what do you call it? The whiteboard, blank whiteboard. So this angle is 5 pi over 6. Let's review. The answer is right. Everything is right. Right, let's just do a little bit extra.
Open with I don't know how to read the whiteboard.
Just stop sharing this screen.
Okay.
Stop sharing this screen. Go to the arrow. You see the first one? Share blank whiteboard. Yeah, you got it.
Okay. Give me a second.
Let's draw the picture.
Sorry.
So we're trying to draw the picture for 5 over 6. So trying to see, you know, how do we draw this one? 5 pi over 6. Well, we can read it as 5 over 6 pi. 5 over 6 is almost 6 over 6, right? Almost 1 pi, but not 1 pi yet.
Okay, so we know that the unit circle. Oh Jesus Christ, this is not right.
It's okay. It's okay. Let's draw the quadrants first. Let me draw the circle for you. Yeah.
Okay. Go ahead.
Let me try. Yeah, let's pretend this is a perfect unit circle.
Okay, so we know that basically this from here to here, this is our 90 degree, then this is our 180 degree. We know that this is pi divided by 2. When we solve that, it gives us 90 degree. And then it's just it keeps like increasing, like 90, 110, 120, and then 135, 150. So actually this, the 150 here, this is the one we are solving. Oh my god, I don't know how to use this. So yeah.
So you're saying, let me use a green color. You're saying we're measuring angle, we're starting from this 0, we're going counterclockwise because 5 pi over 6 is a positive angle. We're measuring counterclockwise to somewhere here, and also you figure out 5 pi over 6 is 150 degree, so the point ends up here.
Correct.
So starting from the 0, we're running around in this direction, we stop at here. Then this point connect with the origin, and then also we drop a perpendicular line to here. So the reference angle of this angle is this guy. It's this angle in the triangle. The triangle falls in the second quadrant. Great.
Correct.
And this angle, right, last class we said, how do we figure out if it falls in the second quadrant? We said, you know, do pi minus the angle, which what you did. You did the pi minus 5 pi over 6, you get pi over 6. So this angle, right, in the triangle is pi over 6, which is 30 degree. Because this is 150 degree. From here to here is 150 degree. And here is 30 degree, or pi over 6. Great job. Thank you.
Thank you.
All right, let's see. Anybody, I think everybody shared, right? Hopefully, Sarah, you can share in the class. All right, so that gives me a chance to try to help you to explain things better. All right, let's now, again, I hope you have questions for me, all right? If I'm not explaining things clearly, you know, stop me and ask. Let's go over some important concepts. Then I give you some more homework. Right, the reference angle, I hope nobody has any questions anymore. Right, you see the angle measure could happen. Let me just emphasize. So the angle measure could end up at the first quadrant, second quadrant, third quadrant, right? So this ends up at the second quadrant. If the second quadrant, what is its reference angle? We look at this triangle. We make this triangle. Then, you know, the reference angle of this one is this angle inside this triangle, is this angle. Second quadrant, we should just do pi minus this angle. This red color measures the angle. If in the first quadrant, we look at triangle of this triangle. So the reference angle of this red color angle is the angle in the triangle, is this one. Is this angle. In the third quadrant, so this one, this is the reference angle for this. All right. It ends up at the third quadrant. Fourth quadrant similar as this one. So that's how we figure out reference angles. We need to figure out the angle ends up at which quadrant. Then draw the rectangle. Then draw the triangle. Draw the triangle. Then the angle around the origin inside the rectangle, inside the triangle, is the reference angle. We defined sine value, cosine value. We said, okay, let's look at this picture of red triangle, right? We can talk about this angle as t, this angle as s, and the sine t equals the opposite side divided by hypotenuse, so I have b over c. Then cosine is the adjacent side over hypotenuse is a over c. And tangent t is opposite side over adjacent side, b over a. Also, tangent equals sine over cosine. If we work with a unit circle, the hypotenuse is 1. The hypotenuse is 1. Right? Then we have a sine of the angle equals to the opposite, which is the y value. Right? Think about a triangle like this. Opposite to the angle is a y value divided by 1. Or just ignore divided by 1, right? It's just y. So cosine of the angle equals to adjacent side next to the angle, adjacent side over hypotenuse, which is also 1. And tangent equals the opposite over adjacent. And cosecant, we don't have to worry about cosecant, secant, cotangent, all right? Only try to remember sine, cosine, tangent. And we have this important table to remember. We have 0, pi over 6 is 30 degree, pi over 4, 45 degree, pi over 3, 60 degree, pi over 2, 90 degree. I did not write here, 90 degree. Then pi, 180 degree. 3 pi over 2, 270 degree. Right? There's some special values. Sine 0 is 0. Yes.
I have a question.
Yeah.
So what would 2 pi be?
2 pi 360.
Okay, because you're going around twice, right?
Right. You go around just once. You go back to 0.
Okay.
So 2 pi. Okay, let me draw this. Let's see we're running around. We're starting from 0, right? 0 is on the positive side of x-axis.
Yeah.
Right. We run up to here, 90 or pi over 2. We run up to here, 180 degree or pi. We keep running. Oops. We keep running up to here. Now this, let me try this. We start from this 0. It doesn't, okay, anyway. So we run here, pi over 2, run up to here, 180 or pi, run up to here, 3 pi over 2, then run back to the point we started. That's 2 pi, 60 degree.
Okay.
So that's why.
So pi is half, right?
What do you mean pi is half?
Like a half of the unit circle.
Oh, yes. Yes. Pi is half of the unit circle. Pi is you're running around straight lines.
Okay,
Yeah,
so
pi,
if you go to the third quadrant, that's pi over
3 pi over 2.
3 pi over 2.
Here, 3 pi over 2, or 270 degree.
Okay.
Let me write it, 270 degree. Then I did not write down 2 pi because 2 pi is the same as 0. We're running around one circle. Okay, good question. Keep asking questions.
Okay.
Okay, so some important value to remember. Sine 0 is 0. Sine pi over 6 is a half. Or sine 30 degree is a half. Very, very important value to remember. Okay, sine pi over 6 is a half. Sine pi over 4 is square root 2 over 2. Sine pi over 3 is root 3 over 2. Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2, negative 1. Okay, sine 2 pi go back to 0. Sine is 0. Sine 2 pi is the same as sine 0, which is 0. Very important value to remember. And the rest of it can be derived. Okay, I don't need you to remember the rest of the value. So we're going to talk about the identities of trig functions. So by the relationship, once you know sine value, you will find the rest of the trig function values. All right. So just work on the first one. Work on the angle, work on the sine value. All right. You need to remember this for calculus class. All right. And then, right, we have 4 triangles in 4 quadrants to work with. So in each quadrant, the sine and cosine tangent value are different. So one thing help us to remember is all students take a calculus. All means in the first quadrant. First quadrant all means every trig function has positive value. Because x is positive, y is positive, and hypotenuse is positive, right? But in the second quadrant, only sine is positive. Because only y and hypotenuse are positive values, and x value are negative, right? So only sine and its inverse cosecant being positive. Others are negative. And in third quadrant, tangent is positive because y value and x value both negative. Both negative. Negative divided by negative will be positive. So tangent and its inverse cotangent are positive. And cosine being positive in the fourth quadrant because x value is positive, y value negative. So cosine and its inverse secant positive. All others are negative. So this will help us to remember. All students take calculus will remember us these trig function values. So let's think about cosine 2 pi over 3. 2 pi over 3 happens in the second quadrant, right? If we draw the angle. In the second quadrant, only sine and cosecant positive, so cosine is negative. But what's its reference angle in this quadrant? That's pi minus 2 pi over 3, which is just pi over 3. So we have cosine 2 pi over 3 equals to negative cosine pi over 3 equals to negative half. All right. So first we need to figure out where is this angle, which quadrant is the angle. We need to figure out, we need to draw the picture to show 2 pi over 3. Then we draw the triangle. So if the angle in the second quadrant and its cosine value will be negative value of cosine of its reference angle. Pi over 3 is its reference angle. It's the reference angle of 2 pi over 3. So this same thing involves, two things, all right? So we draw the angle, then we draw the triangle, right? First we draw the angle, then we draw the triangle. Then we use this. All students take calculus help us to remember which one is positive. Cotangent in the second quadrant be negative of cosine of its reference angle. Well, negative pi over 3, if we draw, that's in the fourth quadrant. In the fourth quadrant, tangent be negative. So we would write tangent of negative pi over 3 equals to negative tangent pi over 3. But then we go to the chat to go to the table to check. Tangent pi over 3 is root 3. So tangent of negative pi over 3 equals to negative root 3.
Professor, do you mind showing that on the unit circle so I could better
Which
understand it?
this one? Negative
The
pi over 3?
yeah, that.
Okay, so negative angle, right? Negative angle means we start from, let's use this one. We start from this 0. We measure clockwise. Negative value, negative angle. If it's positive, the first one is positive, we start from 0. We measure counterclockwise. So that's why we have this negative. Negative pi over 3 is right here. So then we would draw a picture of triangle. Right? We connect this point with the origin, with this origin. Then we drop a line to the x-axis from this point. From this point, we drop a perpendicular line to x-axis. Then you see we formed a triangle, right? With this part of the x-axis, we formed a triangle. Oh, you know what? Let me try to draw here. Right. So we have negative pi over 3. We start from 0. Okay, we start from this 0, right? We draw negative. Negative goes this way. Negative pi over 3. Pi over 3 is 60. We end up here. Right? Then we connect this point. Then we connect this point with the origin. Also, then we drop a perpendicular line to x-axis from this point. Do you see a triangle in the first quadrant?
Yeah.
Okay, what is the reference angle? Its reference angle is this. Oops. This angle is this angle around the origin. This is the reference angle. Because in the first quadrant, basically just absolute value of negative pi over 3. Make sense?
Yeah, so what's the name of that angle?
I'm sorry?
What's the name of that angle?
Reference angle.
Okay.
Who can use reference number?
Okay.
So reference angle, so negative pi over 3, reference angle is pi over 3. But tangent in the first quadrant is negative value. So we put a negative sign here. So we have negative tangent pi over 3, which is negative square root of 3. Okay, anybody else has any questions? Tijeta, do you have any more questions?
No, I'm good for now, Professor.
Okay, I think you missed this class. Let's see this one, sine 9 pi over 4. So 19 pi over 4, we can rewrite as 16 pi over 4 plus 3 pi over 4, right? And 16 over 4 is 4. So we get 3 pi plus 4 pi. And 4 pi, remember 4 pi is just going back to 0 with 2 circles, right? So 4 pi is the same as a 0. So that's why we have this equation. We have sine 19 pi over 4 equals sine 3 pi over 4. Then sine 3 pi over 4, 3 pi over 4 in the second quadrant. In the second quadrant, what's its reference angle? We do pi minus 3 pi over 4, which is just pi over 4. And sine in the second quadrant is positive. So we have positive sine pi over 4. Or sine pi over 4 equals the square root 2 over 2. So to do homework, this homework, we need to draw the picture, all right? Draw the picture. Draw the angle first, then form the triangle. Then remember all students take a calculus, then get the value. Okay, so cosecant is defined as 1 over sine. Secant is defined as a 1 over cosine. Cotangent is defined as a 1 over tangent. This is also important, even and odd functions. So sine of negative t equals to negative sine t. And the cosine, so sine is odd function. And the cosecant is the inverse, of course, is the odd function. Tangent of negative t equals negative tangent t, odd function. Cosine and its inverse, secant, are even function. Remember odd function, even function? Even function means f of negative x equals to f of x. Example is f of x equals to x squared, right? If we put a negative x value, we still get positive x squared because negative x times negative x is x squared, is positive. That's called an even function. What about odd function? Odd function means when we put a negative x negative value, we get a negative f of x. The function to remember could be x raised by odd number, maybe x raised by cube, right? So f of, if x raised by cube, negative x raised by 3 times will still be negative x cubed. So this is the definition of even function, odd function. Okay. Even function, we could see the graph. Remember the graph of x squared? We get a parabola, right? You see negative x still give us positive y value. What about odd function? Let's see x cubed. If we draw the graph of x cubed, let me see if I draw it. Stay? Oh no, it doesn't stay. Or let's use equals to x. X raised by 1, right? X raised by 1, 1 is odd number. So this would be x raised by 1. You see when x is positive, y is positive. When x is negative, y is negative. So this is an odd function. This is the even function. Odd function has a symmetric. So the origin is so it's symmetric, right? It's symmetric. What's the symmetric about? So this symmetric about the origin. But even function is symmetric with y-axis. So that's about even function, odd function. How do we check? We just put a negative x into the function to see if we get f of x or we get negative f of x. Or sometimes a function, you know, either it's neither one. It's not even, it's not odd. Okay, let's say some identities, very important identities. So this is called Pythagorean identity. Sine square of the angle plus cosine square of the angle equals 1. Tangent square plus 1 equals secant square. 1 plus cotangent square equals cosecant square. So the number 1 is very important. The first one is super important. So this one is super important. Okay, we should remember in our head. So sine square plus cosine square equals 1. All right. Sine square of the angle is the same. It's a t, the same angle. Sine square of the angle plus cosine square of the same angle equals 1. So this is super important property. And you know, we could go around to prove that. Let's see questions like this. finding all trigonometry functions from a value of 1. Remember I said if we know sine value, we would know cosine, tangent, and all other trig function values. So let's see that. So here we're given this question, we're given cosine t equals to 3 over 5. So t is an angle, all right? And we're given the quadrant. So this is in the fourth quadrant. So let's look at the picture. So we have, think about, we have a triangle. Go straight. So let's think about this triangle. The cosine value, because it's in the fourth quadrant, right? In the fourth, this is a quadrant in the fourth triangle. And we know in the fourth quadrant, cosine and its inverse secant being positive, all other values of trig functions being negative. So cosine, so this is the angle t. Right? So this is the angle t. The angle we always talk about around the origin. So this is the angle t. So cosine t equals to 3 over 5. So cosine we know equals the adjacent over hypotenuse. So that gives us this triangle value. And this value, the x value is 3. And the hypotenuse is 5. So we form this picture. And if we know this 3, this is 5, we could use Pythagorean theorem to solve for the third one, right? And this is a 4. You may try yourself. A squared plus b squared equals c squared. 3, 4, 5 is a Pythagorean triplet. So if I'm given 1, 2 sides, I can solve for the third side. So this is a 4. But let's see. But this is in the fourth quadrant. In the fourth quadrant, the y value is negative, right? So it's not only 4, but negative 4. Because this is in the fourth quadrant, the y value is negative. So we get negative 4. Well, let's see how we find those values. First one, we want to find sine. Sine, let's use the identity. Sine squared plus cosine squared equals 1. So cosine equals 3 over 5. Let's substitute cosine. 3 over 5 into cosine. So 3 over 5 is 9 over 25. So sine squared, so move to the other side, becomes negative. So sine squared equals 1 minus 9 over 25. So 1, we can change to be 25 over 25. Then 25 minus 9, that's 16. So we get 16 over 25. Then we square root. So we square root of sine squared. When we square root, we get positive, negative 2 values. Square root of 16 is 4. Square root of 25, that's 5. So sine t equals to plus minus 4 over 5. But the triangle is in the fourth quadrant. Sine value is negative. Sine value cannot be positive. So we ignore the positive one. Right? We ignore the positive one. So we just take sine value, sine of t equals negative 4 over 5. Because in the fourth quadrant, sine value is negative. But now let's find tangent. Tangent equals sine over cosine. We just plug in negative 4 over 5 over 3 over 5. We do that, we get negative 4 over 3. And the cosecant equals to 1 over sine. So we just flip this numerator and denominator. So we get negative 5 over 4. And we know cosine. And the secant equals 1 over cosine. So that's just 5 over 3. Cotangent equals 1 over tangent. So we'll flip negative 3 over 4. 4 over 3. So we get negative 3 over 4. Okay, anybody? Oh, I passed the time. Anybody has questions over this? So make sure you understand example 5. So I'm going to leave you some homework. Okay, homework 16. Homework 16. So this is 5.2. Let's do 55. Let's do 4 questions from here, 55 to 58. Then 55, 56, 57, 58. Then 65 up to 68, 69, 70, 70. 6 questions. Okay, total 10 questions. Okay, anybody has any questions? Okay, if not, I see you Friday, all right? Oh, one more thing. We are given this class, so this class is given a tutor. I send you emails, right? If you don't feel comfortable talking to me, you can talk to him, and he can help you with your presentation and with your homework. Okay, anybody has any questions? Okay, I'll see you Friday then, all right? Have a good day.